All right. Hello, IB Physics class. Yesterday we pretty much finished up circuits, and so now I'm going to move on to atomic physics. And so we're kind of going to take the approach of starting at the biggest scale and then going inward. So we're going to learn about. You might remember this model. This is called the nuclear model of the atom. Okay, and the nuclear model of the atom is where you have what's called the nucleus, um, and then around the nucleus you have, you know, all around the nucleus you have the electron cloud. Okay, so what is inside the nucleus? Well, inside the nucleus there are protons and neutrons. Protons, of course, have charge plus E, so plus 1.6 times 10 to the minus 19 coulombs. All right. And neutrons have charge 0. The electron cloud is filled with electrons, and the electrons, of course, have charge minus 1.6 times 10 to the minus 19 coulombs. All right. So if the size of an atom is roughly 10 to the minus 10 meters. Okay, so that means, 10 to the minus 10, that's 1/10 billionth of a meter. So if you have a meter stick and you wanted to know how many atoms go across the meter stick, it's about 10 billion of them. Okay, so this is approximate. Different atoms have slightly different sizes, but it's all around 10 to the minus 10 meters. That's the size of the electron cloud. Okay, now the nucleus, so the nucleus has a size that is much smaller than that. It's about 10 to the minus 15 meters. Okay, so that's 1/100,000th the size of the atom itself. So basically you have a really big electron cloud and a really tiny nucleus in the center of that. Z is called the atomic number. And basically it is the number of protons in the nucleus. Okay, so for example, if the atomic number is 3, then that means there's 3 protons in the nucleus, and that would be lithium, right? I believe it's lithium. The number of protons in the nucleus is also going to be equal to the number of electrons in the electron cloud, so that the net charge of the atom is 0. If there's a different number of electrons in the electron cloud than there are protons in the nucleus, we would say that it is ionized. Okay? So that's the nuclear model of an atom. And so what we're going to do is we're going to kind of go, we're going to start by studying the electron cloud. and then we're going to study the nucleus, and then we're going to study what's inside the nucleus. So we're kind of going to be zooming in. We're going to be zooming in to the atom as we continue to learn more and more about it, okay? So what we're going to do first is we're going to study what are called energy levels. Okay? And it turns out, so we're starting out with the electron cloud. That's what we're studying. So it turns out that the electrons in the electron cloud can only have certain energies. So that means, you won't necessarily have, you might have an electron, it could have 5 joules of energy, but it can't have 5.1 joules of energy. Okay? You can only have certain amounts of energy, and those are spaced apart. So you might be able to have 5 joules of energy, you might be able to have 7 joules of energy, but the electron can't have 6 joules of energy, or any of the energies in between. Okay? So these are called energy levels. I kind of like to think about it like when you go to a movie, right? It's like you have a seat in the movie theater. You can't just sit wherever you want. You need to sit in a seat, okay? And these are the energy levels. The energy levels, I should say that the energy is best measured because atoms are very tiny. The electrons have a very small amount of energy, and so a joule is actually way too large of a unit of energy. So this energy is best measured in what are called electron volts. Okay, and 1 electron volt is a very tiny amount of energy. So 1 electron volt is 1.6 times 10 to the minus 19 joules. So it's the same as the charge of a proton. It's just instead of coulombs, it's joules. Okay. The electron energies. Let me shift this. The electron energies will be negative. Okay. Now, why is that? Well, negative energies represent something that is bound, something that is stuck. So the electrons are stuck in the electron cloud, and so they have negative energy. 0 energy is the moment when you're free. Okay? So if something has, like for example, minus 5 eV of energy, and you give it 5 eV of energy, so now its energy has gone from minus 5 to 0, and it's free. Okay? Christian has asked a really excellent question. Are the energy levels visualized by the Bohr model of an atom? Yes. Okay? Another thing I wanted to say is anything 0 or above is free. So if you have an electron with minus 5 eV of energy, and you give it 5 eV of energy, then it's free, but it has no extra energy. So you've basically just unbound it from the nucleus. You've unbound it from the nucleus, but it's just going to sit there. If you have an electron that has minus 5 eV of energy and you give it 7 eV of energy, then it's going to have an energy of 2 eV. So it's going to be unbound from the nucleus, and in addition to that, it's going to have extra energy that's going to let it fly around someplace, okay? So in general, these are going to be negative. All right. So let's say, so typically you have an energy level diagram. Okay. And at the top of the energy level diagram is 0 eV. So again, if you have above 0 eV of energy, that is freedom. Okay. And then maybe there's some energy levels down here. So maybe this is minus 5 eV, like I was saying. Maybe that's minus 8 eV. Maybe that's minus 6 eV, or minus, I'm going to say minus 12 eV. And then maybe this one is minus 20 eV. So we have 4 energy levels here. So an electron can sit in any one of these energy levels, okay? So let's say you have an electron that's sitting here with minus 12 eV of energy, okay? If you gave it exactly 4 eV of energy, it would bump up to this energy level, okay? If you gave it exactly 7 eV of energy, you would bump it up to the minus 5 eV energy level, okay? But what would happen if you gave it 1 eV of energy? If you gave something with minus 12 eV of energy 1 eV of energy, then that would bump its energy to minus 11. And you can see that there is no minus 11 eV energy level. So it can't accept 1 eV of energy. It's kind of like an all or nothing approach, okay? So the electron has to stay put unless it gets exactly the right amount of energy, okay? By the way, these energy levels are just arbitrary. Every atom is going to have different energy levels depending on its type. And in fact, one of the things you do in quantum mechanics is you calculate what these energy levels would be. Okay, so I'm just making these numbers up for hypothetical purposes, but you know, if you were a nuclear physicist, you might be calculating these things. Okay, so what would happen if the electron dropped to the 20 eV energy level, minus 20 eV energy level? Oh, I got a question here. What would happen if it was, say, given 5 eV? Would it sit at the minus 8 eV energy level? So you can see that the difference between minus 12 eV and minus 8 eV is 4 eV. So the only amount of energy it could accept is 4 eV. So in that case, nothing would happen. It can't accept 5 eV. Okay, so what happens if an electron drops an energy level? So this electron, if it went from here to here, it lost 8 eV. So according to conservation of energy, that would mean that it gave up 8 eV of energy. So where does that energy go? And it turns out that it goes into what's called a photon. So the electron, as it transitions between energy levels, it's going to spit out a photon. Okay? A photon is a particle of light. Okay? So light is made up out of photons. And the energy of a photon is related to its color. So, okay, so there's a formula for the energy of a photon, and it's equal to H times F, where F is the frequency of the photon, which corresponds to its color, of course. And H is a constant of nature. It's called Planck's constant. And its value is 6.6 times 10 to the minus 34 joule seconds. Okay? So we can see that as the frequency becomes larger, the energy goes up. So actually, this means that bluer photons have more energy. Redder photons have less energy. Okay, so if the electron transitioned from here to here, then that would mean that it spits out an 8 eV photon. Now, what if I had an electron in this energy level, and what if it was, boom, hit by a 7 eV photon? In that case, it could actually jump up to that energy level. So basically, how an electron changes between energy levels is it either spits out photons or it absorbs photons. Okay? So let's suppose that I have a minus 5 eV photon, or electron, and it falls all the way down here to the minus 20 eV energy level. And I wanted to know, what is the frequency of the photon that was emitted? Okay. What I would do, well, basically the energy of that photon would be 15 eV, because the electron lost 15 eV to do this transition. So I'm going to convert that to joules. So 1.6 times 10 to the minus 19 joules is 1 eV. Okay. So plugging that. So I get 2.4 times 10 to the minus 18 joules. Now, why was it important to convert that to joules? It's because I gave you Planck's constant in joule seconds. Okay. You can also find Planck's constant in electron volt seconds, but I don't have that one memorized. I only have the joule second one memorized, so that's what we're using. So then I would set that equal to HF. So I have 2.4 times 10 to the minus 18 equals 6.6 times 10 to the minus 34 F. And I can solve for the frequency of that photon. and I get the frequency of that photon is 3.6 times 10 to the 15th hertz. That would correspond to a certain color, okay? And yeah, so that when I say color, I mean that loosely. It would correspond to a certain part of the electromagnetic spectrum. So if this frequency was not in the visible part of the spectrum, it could be an infrared photon or an ultraviolet photon, etc. All right. So on Monday, we'll sort of delve deeper into this, and I hope you guys have a great weekend. I'll be posting the circuits quiz today for you guys. So hope you have a great weekend. Bye-bye. Thanks for watching.